Okay, good morning, finite math students. Actually, almost good afternoon. Let me just quickly give you a brief introduction to Mathematica and how to use it for solving some of your homework problems, okay? So first, why don't we go into your homework? Oh, let's see. I'm already in D2L, and I'm going to click on My Labs Plus. Okay. And in my case, let me see, course tools, assignment manager. Okay, and this is the first homework assignment. As you can see, it's due August 31st, which is next Sunday. So let's do a preview. Okay, and I'm going to minimize the larger window. Let's see. Make that a little narrower. And I'm going to, let me minimize this for a moment. Let me launch Mathematica. Okay, I want a new document. Okay, that's a little small. So what I'm going to do, guys, is I'm going to click on Format, Edit Style Sheet, Input, and I'm going to change my font a little bit so that, it's easier for me to read, more attractive. Show fonts. Let's make it 18. And I like Arial. And how about Midnight Blue? Okay. And I'm going to do the same thing for the output. I'm going to make that bold. On a Mac, you could make it bold just by clicking Command B. Excuse me. Show fonts. 18 points. Arial. Midnight Blue. I mean, obviously, guys, this is optional. This is up to you. I prefer larger font. You can play around with your colors, and you can add a background if you like. Let's see. For example, with output highlighted, not input but outputs, I can go to Format and then background color. How about a light green? That's kind of pretty. Again, you're just making it, a little easier for you to read, and that's always a good thing. And you're trying to personalize the app is really what you're doing. You're personalizing the app so that it's easier for you to use. Okay, I hope that makes sense to you. I'm going to close that. Let's see. Excuse me. A little yawn there on a Monday morning. I don't want to make that too narrow because then I won't be able to read it. That's my dog barking in the background. The joys of working from home, right? Okay, so here we have the equation 6m plus, this is question number 1. Your numbers may vary a little bit. Your numbers could be different, right? We have a simple high school algebra problem. So we have 6m plus 18 is equal to 9m minus 3. And we're going to do solve 6 times m, or you could do 6 space m plus 18 is equal to, notice I'm using the double equals symbol. Okay, the double equals symbol. I'm not doing this. Okay, I'm using the double equality symbol. 9 times m, or 9 space m, minus 3. The space means multiplication, right? And then I'm trying to solve for the variable m. M is equal to 7, and if I want to get rid of the external list braces, I should flatten my output. M is equal to 7. M is equal to 7. Is that correct? Yes, it is. Let's move on to the next question. Okay. Let me squeeze this down. Let me resize the window a little bit. Okay. Similarly, we have solve 3 times, or just 3 space, your choice, x minus 3 plus 14. The double equality symbol. Okay, you're going to get in big trouble if you do this. You're going to use the double equality symbol. 2 times x plus 5. I'm solving for the variable x. Okay, so x is equal to 5. I mean, it's pretty simple. It's pretty simple. Okay, and let's check the answer. Okay, so I think you guys understand what's going on here. Before we move on to other questions, let me explain something to you. There is a big difference in Mathematica and in most computer languages actually between the single equal sign, okay, and the double equal sign. Okay, so for example, is 5 equal to 5? That is true. Is 5 equal to 4? That's false. And by the way, when you want to execute a command in Mathematica, you hold down the Shift key and then you press Enter. You hold down the Shift key and you press Enter. Let me repeat that again because I'm sure some people are not doing it. In order to execute a command in Mathematica, you type your command and then you press Shift, you keep pressing it, you hold it down, and then you press Enter or Return. Okay, so 2 plus 3 plus 1, Shift Enter, I know it's 6, right? Okay, getting back to the difference between the single equal sign and the double equal sign, there is a big difference, okay? So for example, let's say I want to define a function, right? F of x is equal to x, how about 3 times x plus 1? Okay, so what is f of 2? F of 2 is 7, because 3 times 2 is 6 plus 1 is 7. What is f of 0? F of 0 is 1, because 3 times 0 plus 1 is 1, right? What is f of 9? What do you think it's going to be? What's 3 times 9? I know it's 27 plus 1 is 28. The answer should be 28. Okay, so the single equal sign is used when you're defining a constant, a variable, a function, anything like that, okay? If I want to remove f from memory, I would simply type clear f. And now f is gone. So if I type f of 3, I am simply going to return, well, Mathematica will simply return f of 3. Okay, very simple. Okay, this isn't rocket science. The double equality sign is different. Is true equal to false? It's not. Is true equal to itself? It is. Is false equal to itself? It is. Okay. Is 1 equal to 1? It is. Is 1 equal, what? Is 1 equal to 1.0? All right, now that's a tricky one because really and truly 1 is not the same as 1.0. 1.0 is a floating point number. 1 is an integer. Let's see. 1 is an integer. 1.0 is a floating point number, which is also called a real number. So the double equality sign does have limitations, but what if I want to use the triple equality sign? 1 triple equals 1.0, the answer should be false. Okay, the answer is false because I'm comparing an integer to a real number, and technically in mathematics, integers and real numbers are not exactly the same. Okay, so I showed you the single equal symbol, the double equal symbol, the triple equal symbol. Let's move on and do a few more of these problems, okay? Let's do something a little bit more challenging. And let me expand this window. Okay, let's do a couple problems that are a little bit more challenging. And for some reason, this is not letting me scroll. Ugh. Okay, there we go. Now I can scroll. Okay, the joys of modern electronics technology, right? Let's see. Let's do something a little bit more interesting. 1 second. Okay, so here we have, we're going to end up, let me see. I'm looking at problem number 20. This looks fun. A jazz concert brought in $124,000 on the sale of 8,000 tickets. If the tickets sold for $10 and $20 each, how many of each type of ticket were sold? So there are 2 types of tickets. This is going to lead to a system of equations. So there are 2 types of tickets. All right, we have 2 types of tickets. So it says here, a jazz concert brought in $124,000 on the sale of 8,000 tickets. If the tickets sold for $10 and $20 each, how many of each type of ticket were sold? So we have 2 types of tickets. We have ticket 1 and we have ticket 2. Okay. And we know that ticket 1, let's say, costs $10, and the ticket 1 costs $10 and ticket 2 costs $20. Okay, so we're going to have a system of linear equations, and it's going to look like this. $10 times ticket 1 plus $20 times ticket 2 is equal to $8,000. And what's our second equation? Our second equation, oh, sorry, no, this should be $124,000. $124,000. By the way, I didn't type that comma. Mathematica is typing the comma for me. It's entering the comma automatically. I did not type this comma. I did not type this comma. I formatted Mathematica so that large numbers include the commas. If you don't want to do that with your copy of Mathematica, that's perfectly fine. So I have 10 times ticket 1 plus 20 times ticket 2 is equal to $124,000. And I also know that I sold 8,000 tickets. Okay, 1 second, let me expand this a little bit. And my variables are ticket 1 and ticket 2. Okay, so I sold 3,600 of the first ticket and 4,400 of the second ticket. So let's see if that's correct. The number of $10 tickets, or ticket 1, was 3,600. 3,600. That's correct. And the number of $20 tickets, that's 4,400, yes? So that should be 4,400. And that's correct. So that's a system of equations, okay? What I have there is a system of equations. Now let me explain something to you. I want you to watch your screen closely. I'm going to press the number 1 and a bunch of zeros, and I'm not typing any commas. Hey, why is this? Okay, there we go. I didn't type any commas. So I formatted my copy of Mathematica to include those commas for me. I, however, did not type them. Mathematica is putting them in there for the sake of readability. Okay. Let me see here. If you want to know how to format Mathematica, you would go into Option Inspector. Selected notebook means the change will affect only the current notebook that you're using. And let me see, what is that called again? Not print precision. I think formatting options. You know what? I think I forgot that. I would have to look that up and get back to you. Automatic numbering options. Well, print precision is the number of digits after your decimal place. Here we go, the number separator. The number separator. So I have a comma here. You would have to double click on this, and then you probably have a thin space here. You would have to double click on that and change that to a comma. Do you really have to do that? No, you don't have to do that. I'm just doing it because I happen to like it. But it's not really necessary. Again, this is just something that I did because I want my notebooks, my Mathematica notebooks, to be more readable. But again, this is an optional thing. It's a cosmetic thing, okay? It's strictly cosmetic. Let's go on to another example. We're going to do one more homework problem, and that's going to be it, because otherwise this video is going to be really long. Let's go on to another assignment. I mean, not another assignment, another question within this assignment. This is an interesting problem. You have $500,000 in an IRA, which stands for Individual Retirement Account, at the time you retire. You have the option of investing this money in 2 funds. Fund A pays 3.7% annually, and Fund B pays 6.2% annually. How should you divide your money between Fund A and Fund B to produce an annual interest income of $26,750? Okay, so for this here, let me shrink this down. Let me resize the window. So you have $500,000, okay, in your retirement account. Fund A pays 3.7% annually, and Fund B pays 6.2% annually. And we want to know how to split up this money, okay, so that I have an annual interest income of $26,750. So what I would do for this problem, it looks like you need two different variables. I would argue that maybe we could solve this with just one variable, although actually, no, let's use two variables. Let's use two variables, okay? So we have amount 1 and amount 2. And we should agree, I hope that we all agree, that when I add up amount 1 and amount 2, I'm going to get $500,000. Okay, so I'm going to solve a system of equations. Amount 1 plus amount 2 is equal to $500,000. Okay, I just pressed enter to go to the next line, not shift enter. And let me see. Well, you know what? I should really call this amount A and amount B in order to be consistent with the names of the variables in my word problem, right? Okay, so amount A, and I could even call this Fund A. Let's call this Fund A, and we'll call this Fund B. You can call it whatever you want to call it. Okay, and Fund A pays 3.7%, which is 0.037 times, you can use the star symbol or just space, Fund A plus 0.062 space Fund B, the space means times, and that's equal to $26,750. Close my list. Okay, those curly Q brackets, those are called list brackets, right? And I'm looking for the values of Fund A and Fund B. Okay, I want to solve for those values. Okay, so Fund A, I should invest, oops, 1 second. I should invest $170,000 in Fund A and $330,000 in Fund B. And let's see if we're okay with that. Let's check the answer. Fantastic. Okay. So I want to explain a few more things about Mathematica before I end the video. All right? So I'm going to close the homework, and no, okay, I'll just keep that minimized. Let me expand this. Okay, expand my Mathematica notebook. If you're, okay, there goes the dog again. Okay, just ignore it. If you're going to solve for a variable, Chachki, stop! If you're going to solve for a variable in an equation, that variable cannot be predefined. So for example, let's say I decide that x should be equal to 2. Solve x, or how about 3 times x minus 1 is equal to, oh, I don't know, let's say equal to 12. What is x? Okay, so I think we're going to get a fraction here because in order to solve this equation, I would add 1 to both sides. I would have 3x is equal to 13. X should be 13 divided by 3, but that's not the answer that I'm going to get. Okay, it says here 2 is not a valid variable. Why is that? Why? Because what I have here is the equation 3 times 2 minus 1 is equal to 12. 3 times 2 is 6. 6 minus 1 is 5. 5 is equal to 12. It's false. So you cannot do this. You cannot assign a value to a variable and then try to solve for that variable later on, in a separate Mathematica command. That's not going to make any sense. So in order to fix that problem, I would clear x, okay, and let's try this again. Solve 3 times x minus 1 is equal to 12. What is the value of x? Flatten the output. Okay, so I know that x is equal to 13/3, and the reason I can do that now is because Mathematica is treating x as a symbolic value rather than as the number 2. Here, Mathematica thinks that x is equal to the number 2, okay? And that's why I'm getting this warning message, 2 is not a valid variable. Here, however, on this line, okay, input line 31, x is being treated as a symbolic value rather than a number. And so I'm able to solve the equation x is equal to 13/3. Okay, so that's just a brief introduction to this is a brief introduction to Mathematica and your first homework assignment. More videos to come later in the week. Okay, thanks. Get to work on your homework, and if you have problems, please email me with your questions. Okay, thank you, and have a wonderful day. Bye-bye.